Hello everyone, welcome to my YouTube channel TechSpot. This is me, Harish Gaupale. In today's video, we are going to discuss about two types of digital circuits such as combinational circuits and sequential circuits. Also, we will discuss what are the procedural blocks available in Verilog and in System Verilog to implement the combinational circuits as well as sequential circuits. So let's get start with the combinational circuits. So basically, what is combinational circuit? So in combinational circuits, output is depends on the present input. Once input is applied to the combinational circuits, then it is reflected in the output after the logic gate delays. Okay, and as it depends on present input, so it does not have any memory elements. Okay, and it is used for the arithmetic operations such as addition, subtraction. Also it is used for data routing such as mux, demux. Also it is used for code conversion such as encoders, decoders, and also it is used for control circuits such as state machines. Okay. For examples, basic logic gates such as AND gate, OR gate, NAND gate, NOR gate, multiplexers that is used for data routings, demultiplexers also, encoders, decoders, and arithmetic operations such as half adders, subtractors. These are the examples of conventional circuits. Now we'll jump to understand what is the sequential circuit. So basically, in sequential circuits, output is depends on both present input and past output. As it is depends on past output, it has memory elements. Okay, and it is used for the memory storage such as flip-flops. As we know, D flip-flops or T flip-flops will be used act as a storage element. We can store one bit of data in D flip-flop. Okay. Also, it is used for counters and timers, counters such as up counter, down counters. Also, it is used for control systems such as state machines, Murray machine, Mealy machine. Also, it is used for data processing, and it is used for synchronous and asynchronous logic. For examples, latches such as SR latch, D latch, T latch. Okay, flip flop such as D flip flop, T flip flop, SR flip flop, JK flip flop. Counters, we know that up counters, down counters, ring counters. These are the examples of sequential circuits. So now we'll discuss what are the procedural blocks or constructs are available in Verilog and System Verilog for the design implementation of conventional circuits. On my screen, you can see on first side I am having Verilog procedural blocks. On the other side, I am having System Verilog procedural block. So let's understand each procedural block one by one. So this is my first procedural block, that is always at the rate and sensitivity list. So basically the sensitivity list is nothing but the signals. We have to mention whatever signals we are having to implement the combinational blocks. Below that you can see this is the syntax that is used while implementation of the combinational blocks. Okay. Above that, sorry, below that, you can see always at the rate star. So basically here star is the wildcard operator. This wildcard operator automatically will take all the sensitivity list. So while implementing design by using always at the rate star, we don't need to give the sensitivity list. Below that you can see the syntax always at the rate star, begin, end, and end model. So basically, if I talk about the difference between always at the rate and always at the rate star, so the main difference is about the sensitivity list. In always at the rate, we have to mention the sensitivity list. In always at the rate star, we don't need to worry about the sensitivity list. Now, as we know that System Verilog is the upgraded version of Verilog. So in System Verilog, we are having single procedural block that is called as always com. So below you can see the syntax of always comb that is useful for implementation of combinational circuits such as mux, demux, encoders, decoders. So these are the procedural blocks are available in Verilog and System Verilog for the combinational circuits. Okay. Now we'll understand what are the procedural blocks are available in Verilog and in system Verilog for the design implementation of sequential circuit. On my screen, you can see on left hand side, I am having Verilog constructs or Verilog procedural blocks. On the right hand side, I am having a system Verilog procedural block. So let's understand each procedural block one by one. So the first procedural blocks that are available in Verilog, that is always at the rate POSIX clock. So basically, this will act as a synchronous reset, and it will execute the logic based on positive edge of clock only. Below that, you can see this is the syntax that is used for the always at the rate POSIX clock. Below that, we are having a second procedural block such as always at the rate POSIX clock or negate reset time. So this procedural block also execute the logic on the POSIX clock only, and but it will act as a asynchronous reset. Below that, you can see this is the syntax of the always at the rate POSIX clock or negate resettion. So the main difference between always at the rate POSIX clock and always at the rate POSIX clock or negate resettion is this will act as a synchronous reset and this will act as a asynchronous reset. Okay. Now in system Verilog, we are having two procedural blocks. One is always latch and another is always FF. So the first is always latch. So basically the always latch is used for the implementation of latches only. Intentionally, this procedural block will implement the latch, and this is the syntax of always latch. Okay, and below that you can see we are having always FF. So always FF used for the implementation of flip flops that is working on the process clock only. Okay, so these are the procedural blocks are available in Verilog and system Verilog. So here I will stop the video. So if you are watching this video, then please like the video and subscribe my YouTube channel and share with your friends also. Thank you so much.